As the number of people using the internet as well as smartphone users have nearly doubled within the past decade and just about 50% of households worldwide have a computer at home, software applications or programs increasingly got relevant in our daily life. So it's no surprise that software developers, engineers and programmers are the top scorers of almost every list of today's most demanded professions. And you might even have noticed for yourself that your time spent in front of digital devices significantly has increased during the past 5 to 10 years.
Hey look, there's a video of a cat playing the piano.
Why are you like this? But what exactly is programming and how does it work? So what do water parks, recipes and programming have in common? Well, imagine sliding down a water slide. You will always enter it at a defined starting point and at the end come out at the bottom. The path between these two events can be shaped in very different ways. There might are straight lines, turns or loops. In theory, even junctions or different conditions are conceivable. But all in all, you will run through these steps in a predefined order, similar to cooking according to a recipe. Mixing eggs with flour is useless before the eggs haven't been opened. An algorithm is not that different. It is an instruction for solving a problem by running through a finite list of single steps. Programming can be seen as formulating algorithms and constructing a system of multiple interacting components, so-called objects like your water slides in the water park.
Consequently, a program or executable is a finite sequence of machine language instructions for your central processing unit, the CPU, which every computer, smartphone or similar device must have.
Machine language instructions are sequences of binary numbers, so 1 and 0 only, which can be executed by the CPU directly. But how do we get from our problem to our machine code? It's almost impossible to transform our idea of what our program should be doing straight into just ones and zeros. We need someone who can translate our idea of a water slide for the construction worker who unfortunately only understands machine language. The solution are programming languages, for example Java, in combination with a compiler or an interpreter. A compiler takes the complete source code written in your programming language and transforms it into the machine language instructions needed by your CPU, creating an executable program. An interpreter passes the source code just in runtime, line by line, performing the instructions directly and without creating an executable program.
As you can imagine, there are advantages and disadvantages on both sides in terms of compatibility, debugging and execution speed. Which technique is applied mainly depends on what programming language was used to write the source code.
So let's talk about language, grammar and dialects for a moment. Programming languages can be separated and assigned to two main programming paradigms. The first one is the imperative or procedural paradigm. A procedural program, just like explained before, is defined by a certain sequence of instructions, while input values are stored in variables and get processed from there on. Examples for procedural programming languages are BASIC, C, COBOL or Fortran. On the other hand, we have the object-oriented programming paradigm. These programs are not defined by the order of their instructions, but by objects and their communication with each other. An object has temporarily changeable states, or variables. This could be an information. Is somebody in our water slide or not? Moreover, an object has a certain behavior, so-called methods, like the course of our water slide. Object-oriented programming languages are C++, C#, Java or Python.
Then let's go. How can we write our first source code? Technically, we could write it down in a simple and standard text editor and then pass this file with a fitting compiler or interpreter.
But in practice, this is done within integrated development environments, IDEs, which are software applications themselves, assisting you in the programming process. IDEs like NetBeans or Eclipse even come with their own compilers and interpreters. Main tasks of IDEs are speeding and cleaning up the programming process by completing code segments automatically, visual separation of code segments, or offering various debugging options. Of course, high-end IDEs come with much more functions than mentioned.
Okay, these were a lot of terms in a short period of time. Nonetheless, you hopefully got a quick overview about what programming is and how it works in general within the past few minutes. And if you're interested now in understanding more about programming or even other topics, or maybe just are forced by your universities or teachers to do so, then please let me know about it in the comments down below. Thanks for watching.